Welcome back. I'm George, and as always, I'm here to help serve you in any capacity that we possibly can. So, if you get an opportunity, of course, do the subscribe thing. Yep, share us with your friends. Now listen, there'll be a little bell that'll show up when you subscribe, and all that is a notification icon. If you hit that, you'll be notified every time we publish a video. And that's the only recognition that this channel gets is from subscriptions. So you can always contact me. I'm always available, almost. But if not, I'll call you back. Now, let's get down to what we're going to talk about today. And you can see that I've already got this written on the board. Please don't let that scare you away. 200 proof ethanol, or 100%. Is that possible? Well, it kind of begs the question. And in thinking about doing this video, I had considered several times of not doing it, but there's a couple different reasons why. Now follow this, okay? Real simple. First of all, there are too many people that make a claim that I made 200 proof alcohol. Okay, first of all, that's not true. We already know that. That's just like mash turning to vinegar. That's not true. We already know that. There's a lot of things we know. And another one is, well, you have people that, I just want to get as strong as I possibly can. Well, and I understand that. But remember, when you're getting into, my golly, if you're making it really, really strong, you're actually making fuel. You're not making a drinking spirit. You follow me? Okay. Furthermore, when we're working with, as an example, let's work with a mash. And we put that together. And we're always searching for the highest ABV we could possibly get. We've talked about alcohol by volume, ABV, many, many times on here. I personally shoot for 1.090 or in that neighborhood. Almost never any higher than that. And there's a purpose for that. And the purpose is that when you get any higher than that, you're really starting to create fuel as opposed to a drinking spirit. Most commercial distilleries, their standard is anywhere between 8 and 11%. Now, I know I'm a little bit higher. I'm about, 12.5%, 13% alcohol by volume, so I think I'm splitting that happy medium. I am collecting a high grade, I'm collecting a high grade spirit in a little bit larger volume than I normally would. So what I'm doing is I have a little bit more, but I still retain the character and flavor of the mash. When you get into the upper teens and the low 20s percents of ABV, well, you've stripped out every bit of that because what actually takes place is, and this is a real short conversation, the yeast actually morph and they'll change into something you're not anticipating, and they'll start, of course, the dead ones, the live ones will start eating some of the dead ones. I mean, things start to take place that you're not necessarily expecting. Okay? So, for those of you who are searching for that 19% ABV, cut it back a little bit. You get a better tasting spirit out of it. All right, on to 200 proof or 100%. Is it possible? Well, I got the markers out. That means we're going to do a couple of drawings, and I'm going to try to walk you through this. And so this will be an evolution of information. And please, if you bear with me, I'm not trying to get technical. But what I need you to understand is that if you do understand every aspect of this, it opens up the doors. It makes sense. Okay? All right, let's do this. 200 proof, 100% alcohol. Is it possible? No. Up and yes. But let me explain what I'm talking about. Through the normal distillation process, your limit for alcohol production, and that is if your reflux is working perfect, and you're allowing it in the chamber to balance and to reflux, and your temperatures are right on and your water flow is right and you pump it, if you get a perfect run, your limit for alcohol production, and this is of course, and these are always graduated, the hydrometer is graduated 60 degrees Fahrenheit, is 95.6%. It's like 191 proof. So what that means is that we do know that at 95.6%, that means that no matter what you do, no matter how you run it, no matter what you do through that entire process, that your result is always going to be 4.4% water. That is of your volume, okay? I mean, that's pretty simple. That's straightforward. Now, let me ask you, at 95.6%, or what this is really is 191.2 proof, do you really need it any hotter than that? Well, now you're really at fuel. But in order for fuel to be efficient, you know, the ethanol additives in the fuel, we can get as close to 100% as possible. But well, we just can't do that with a regular still. It's just not going to happen. So I need you to understand that. You've hit your limit. And I would also submit to you that very few people will hit your limit. If you hit your limit, good. I would caution you before bragging about hitting your limit, though, that when you check your hydrometer, make sure it's at the proper temperature. Yes, there is a correction factor based on differences in temperature. So 60 degrees Fahrenheit is what this is calibrated at. So, and it's not on here, but you can convert that to Celsius. But it's calibrated at 60 degrees Fahrenheit to give you an accurate reading. If you're either above or below that, of course, your reading's going to be off a little bit. So therefore, is it possible? Not for us in normal cases. So let's take this another step further. Now, I have this test cylinder, and I've got it filled with some ethanol that we ran off. It's pretty high proof. It's like 168. Yeah, it's 168 proof, but that's 84%. So this particular ethanol is 168 proof, 84% alcohol by volume, which means in order to get to 100%, that means 16% of this fluid is water. You follow that? So if I took the 16% out, it would be 100% ethanol. But that's what I've got right now, and that's a pretty good run. So, but it's still it's rather high. So of course that was done through a reflux. Now you can achieve that with a pot still, but it'll probably only be the beginning of one of your jars. Because of course in a pot still it precipitously goes lower. We're going to do a video on that to explain why. Now that brings us to let's take a look at this, and we're going to talk about this one in particular. Okay, that's this one, and this is the one we're going to use. This is where all of our data points are going to come from, and we're going to demonstrate for you. We have 1 quart, that's 32 ounces, or about 946 milliliters. And we've got this thing full of, what did we say? It's 168 proof. So we already know that 16% of that, what's that, right here? 16% of that is water. H2O. What does 16% of this 32 ounces equate to? I've got a calculator. It comes in handy. 32 times 0.16, and that's going to give us, yeah, 5.12 ounces. We've got, let me change the color. We've got 5.12 ounces of water. Or better yet, we've got 151.4 milliliters. Okay, now this is what has diluted this down from 100% down to 100, well, 200 proof down to 168 proof. You still with me? Now, before you fast forward and try to get to the end of this, because it happens a lot, and I understand that, but if you miss the middle of what we're going to talk about, you're going to miss a lot, and you'll never be able to explain it. So, what is a method of removing this water from the ethanol water mixture? Heat. But what happens? We've got so much ethanol in here, and remember that ethanol is going to boil off. And it all depends on what reference you look at, because a lot depends on sea level, atmospheric temperature, all of your environmental influences. Somewhere around 78 degrees Celsius, I think it's 78.3, or 172.8, I believe. Yeah. And we know that water, there's a data point for water, and that is 100 Celsius or 212 Fahrenheit. So we know that's going to happen. But if we want to get this water off of here, there's no way we can use heat, because if we went to 212 or 100 degrees Celsius, we far surpass the ethanol. So what's going to happen? The ethanol is going to go out. So we're going to wind up with less ethanol than winding up with less water. So I submit to you this: what would happen if we took the 84%, and it has 16% water, and we were able to subtract that 16% water? What would we have? You got it. We would have 100% ethanol, and we would have 0 water. Now, is that possible? Well, it is, but it's not possible through the distillation process. Oh boy, we're getting somewhere now. Please, don't turn us off, because we're getting there. When you look at that, if you look at ethanol and water on a molecular level, now, and I want to give thanks to an individual. I've been working on this for, gosh, months and months, but it was actually a comment that was posted by a viewer that claimed to have found a way to get ethanol without distilling at all. Now, theoretically, okay, but practically, not so much. But it kind of moved me in that direction, because I've seen that people are already trying to go down that road. So I want to explain this. You've got, this is the ethanol. And ethanol has 6 hydrogen atoms, 2 carbon, and 1 oxygen. Simple. Don't let this confuse you, okay? And then, of course, H2O, 2 hydrogen and 1 oxygen. So what do we have here? We already know that there's a covalent bond here. Don't worry about that. Most of the electrons will go around the oxygen, so this is always going to be negative. We already know that oxygen it has a negative charge. These are all positive. Bear with me. Bear with me. And we've talked about this before in one of the other videos. And what happens is there is a opposites attract. Okay? If you do any research and study, you'll find out that ethanol has an affinity for water. That's another reason you can't get to 100% through normal distillation, because it has an affinity. That means it's looking for it. It'll pull it right in. And how does it do that? It does that by these positive charges to this negative charge, because opposites attract. And given an opportunity, ethanol is going to grab onto some water and pull it in, okay? I mean, it's as simple as that. Now, here's what happens during the distillation process. Now, you know that all of these are actually moving. Their vectors and their velocities are all different. When you start, now, and they're also connected. Negatives to positives, positives to negatives. And then like charges repel. So these are connected all throughout your mixture on a molecular level. When you start to heat them up, okay, look at the bonds that need to break in order for a substance to separate, okay? So let me show you what we've got here. The attraction between these two molecules, and these are two single molecules, and this happens on a grand scale. Two single molecules that have an affinity for each other, which means that this ethanol molecule is going to look for a water molecule. It has an affinity for it, so it wants to be there with it. When you start to heat them up and all of these atoms start to fly off in different directions, different velocities, different vectors, things start to happen. They start to get weak and they start to break away. They start to break off. This one can be excited because you have so many hydrogen atoms that when it gets excited, it can break away from the two hydrogen and the oxygen atom. It can break away from that rather easily. But remember, it's got an affinity, so it will always drag one with it somewhere, from somewhere, and if not, it'll pull it out of the atmosphere. Oh, so we're leaving the water behind because it takes an extreme amount of energy and temperature in order for this to break away and vaporize. Oh, you see, we've just explained how distillation and vaporization of ethanol and water work. It's like having, I use an analogy. You got 28-year-olds, 20 12-year-olds, and 20 18-year-olds all on one dance floor, okay? And you start playing some music. Well, after a couple of seconds or more or so, you know, you start pumping up the music, you know, them 8-year-olds, some of them start to move out, okay? Now, some of those 8-year-olds are siblings of the 12-year-olds. They're holding hands. They're stuck. And the same thing with the 12 to 18-year-olds, so they kind of, you turn the music up a little bit more, and now that connection is going to be broke because they're like, I'm out of here. And then they start to leave. And so you see this separation, and once you get that music up blared so much, eventually you have an empty dance floor because even the 18-year-olds are out of there. So you follow that? I mean, that's a simple analogy about how they start to break. There's still some affinity connection that can even be broken. Okay. So, but in any event, you'll have a couple of those kids that kind of hold hands, stick together, say, we'll leave together. They just take off. Okay? Hopefully I've made that simple. Now, I hope I haven't confused anyone. Remember, we're talking about 200 proof or 100% alcohol by volume, which means there's no water in there at all. We know that, is it possible? Well, no, but then yes, and we'll get to that. But 95.6%, which is 4.4% of water, 191.2 proof, is your distillation limit. That's you're not going to exceed that. That's all there is to it. You ain't going to get there. Okay. All right. We just have to accept that. If you want to challenge it, go ahead. Do what I do. Test everything. And oh, by the way, check me. If we have 1 quart, 32 ounces, somewhere right a little over 946 milliliters, and it's at 168 proof because that's what we measured here, we know that 16% of it is water. So that's going to be 5.12 ounces or 151.4 milliliters. That's how much water's in there. Here's the question. If we had that and we removed all the water, we got rid of that 16%, we'd have 100% ethanol, wouldn't we? Now the challenge is, let's get that water out of there. But we've already discovered that we can't do that with heat because this will boil in vapor before that does, because that's when it happens. Now, when we get to part 2 on this, and make sure you stay tuned and get to part 2, we're going to describe and show you how that happens. Okay? Happy distilling. We'll see you on part 2.